Welcome back, everybody. In this video, I'm going to explain how to use arithmetic operators in C++. So before, we've already used one type of operator, the assignment operator, and we've used that assignment operator to assign a value to a variable. So in this case, we've seen that we can assign the value 2 to this integer called x, and we assign the value 3 to this integer called y. And we're also assigning the value of 0 to an integer called z. Okay, so we've done that before. But what if we want to make a change to that variable after we've assigned it a value? Sure, we could always assign it a new value, like z equals x, for example. But we might want to add or subtract or something like that. So this is how we do it. It's pretty simple, actually. So all we got to do is just say z equals x plus y. That's for addition. So you use the plus symbol for that on your keyboard. For subtraction, you use the minus symbol or the dash. Multiplication is the asterisk symbol, x times y. And division is the slash or division symbol. So it's the one that's next to your shift key on your keyboard, below the enter key. There's another slash that's above the enter key that won't work. That's actually totally different, and it has a purpose. Now, before I explain this last one down here, let's talk about division for a second. So you'll notice that we are dividing two integers, and we're putting it inside of an integer. So let me actually just move that output right here so we can output what the number we're going to get is. And let's make these some nice numbers. So if I divide 10 by 2, we should get 5 whenever I run this, as soon as this compiles and runs. Yeah, so we got 5. Okay. So that was a nice number that divided pretty evenly. But let's say we have 10 divided by 3. What happens there? It should give us a fraction or a decimal. Instead, we got 3. Normally, it would be 3 point something. I think it's, yeah, 3.33. However, in this case, we only have 3. It got rid of the remainder. So that is because we are dividing two integers and putting them into an integer. In order to output this properly, we would have to use the float variable type, and we'd have to make sure that at least one of these was a float itself. So if we say int x equals 10, float y equals 3, and float z equals 0, this should display the full, whoa, what happened here? Oh, right, because of this. Let me comment that out. Okay. I don't know why this window is up here. I like to have my windows at the bottom for debugging stuff. I don't know why that went up there. Anyways, I had to comment that out because you can't, I'll explain this in a second. You can't use a float on that, and you'll see why in just a second. Yeah. So yeah, 3.33333. So that shows us the actual value. Okay. All right, so just to recap, in case that confused anybody, when you deal with division by integers, you want to be careful because you might lose some accuracy there. If I'm dividing 10 by 3, maybe I'm okay with getting 3 as the answer, but most of the time I might want 3.333. And to do that, we need to store these inside of floats. Okay. So what is this modulo thing, and why did I have to comment it out to get that to work? Well, basically the idea behind this operator, which you use with the percent sign, the idea behind this is, what if you only want the remainder? What if you don't care about, for example, the 3 here, but you only care about the 0.3? You can't actually do that with a floating point number, so that's why it did that error on me. So let's explain this with integers again. So let's say I have a really big number like 90, and I want to divide that by 5. And we'll make this a integer again. Okay, so if I divide 90 by 5, and we'll see z again here, just to show you what the modulo is. We'll divide it by 5, and then we'll mod x by y. Okay, so 5 goes into 90 18 times, and there is no remainder, so that is 0. However, let's say we want to do, what's a good one? I guess 4. No, 6. So we'll do 6. We could have done 4, I think, too. Oh, it also goes, okay, 90 is a bad number. Let's not do 90. Or maybe we can do 11. There we go. Apparently a lot of things go into 90, but 11 does not. So 11 times 8 is 88, and then 90 minus 88 is 2. So, or you could think of it as 88 plus 2 is 90. That's what I was thinking. But so whatever is left over from this division is the remainder, and you can only get an int from that. So that's why it won't let you do float stuff. Okay, sometimes this operation is very important for a lot of different things. We'll cover that later on, but mainly it's for like if you have a certain range that you want to keep things within, you want to mod your number so it stays within that range. So that's usually where that pops up. Now, there's a couple more things I want to talk about really quickly. You don't have to do it this way. Like, for example, let's say you have, this is another case that comes up a lot. Let's say you want to increment your x value. So we've got x equals, you could increment, let's say you wanted to make it 1 higher than it was before. You could say x equals x plus 1. You could do it that way. Oh, and you might think that that's perfect, and there's nothing wrong with that, and there isn't anything wrong with that. But there are shortcuts. So one shortcut is to say x plus equals 1. Okay, so what this is saying is we're going to take the thing on the left and add 1 to it. And you can do the same with subtraction. So x minus equals 1. You can also do it with multiplication, although multiplying by 1 won't do you very good. You can also do it by division right there. Here, that would be a little bit more useful. But yeah, so these operators here are a little shorthand for that, for performing that operation on itself. So x equals x plus 1, x equals x minus 1, x equals x times 2, and x equals x divided by 2. Now there's one other shortcut that sort of tells you why this language is called C++, okay? One other shortcut for writing this is x plus plus, okay? And one other shortcut is x is plus plus x, okay? And so when basically the story behind the name is there's a language out there called C, and it was one of the most popular languages, I guess. I don't know too much about the history, but it's still used today in a lot of applications for mainly embedded stuff, like embedded circuit boards and all that, programs that run on those things. It became very popular, and I guess it had a lot of good things in it. But I guess it wasn't good enough, so someone out there made C++. And so the idea is that it's one better than C, I suppose. So it's like C++, okay? That's the origin of the name of the language. Now, what is the difference between x plus plus and plus plus x? Both of these increment x by 1, which does the exact same thing as this, and it does the exact same thing as this. However, this is called post-increment, and this is called pre-increment, because you're incrementing the value after you do stuff with it. So suppose, let's demonstrate this. So we'll say, by the way, you can do stuff like this. Y equals x plus plus, and y equals plus plus x, okay? So let's try both of those. Let me get rid of my C outs for the Z up here. And let's just see what the value of y is at that point in time, and then we'll see what it is at that point in time. And actually, before we do that, let's make sure that x is like 2, okay? So x is going to be 2 there. Let's set it to 2 for both of these, just so that we're not getting confused. So it starts out at 2, we increment, and it starts out at 2, and then we increment, okay? So let's see what happens. Okay, so the first one says 2, and the second one says 3. So essentially, you can see right here that the top one only increments the value, this one right here, x plus plus, only increments the value after you've done whatever you wanted to do with it. So we assign the value to y, and then we increment x, versus this down here, in which we increment x, and then we assign that value to y. So be careful about that. you might you might want to avoid doing this just so you don't confuse yourself. But it is a thing that you can do. There might be reasons for it, so just so you're aware about that. So that just about covers everything for the arithmetic operators. There's definitely some other operators that we'll need to cover before we go too much further, but if you have any questions, let me know. Thank you, Microsoft. So yeah, that'll be it. Thank you for watching, and look forward to the next video. See you then.